Hello, everyone. Get excited because this is a crash course into quadratics. We are now done with the quadratics unit, so this is very exciting. We get to go over everything in roughly 5 minutes, maybe 10. We'll see how many videos this takes. No more than 2, though. I want to remind you, we had 3 objectives. The 3 objectives were objective 11, which dealt with quadratic graphs, right? You learned about the important features of graphs, the shape of quadratic graphs. In objective 2, you learned about a little more about the equations of quadratics, and you went back and forth constantly between factored form and standard form. And in objective 13, we studied quadratic equations where we were solving for x. So let's get right to it, excuse me. All right, so we're gonna do all of this review with one example. Let's say we have the function f of x equals negative 16x squared plus 32x plus 560, and that is our function f of x. All right, f of x equals negative 16x squared plus 32x plus 560. And this equation, this is a negative, by the way, models the flight of an object, the height of an object, x seconds after it is launched, all right, where the outputs represent feet, okay? Let's get right to some of the things that you should understand. So first of all, graphs. When I go to graph this bad boy, I see 2 pretty much vertical lines. So let's talk about adjusting our window, all right? I can zoom out all I want, but it doesn't really produce much of what I'm looking for. Now, one of the first things that we learned about the graph is the y-intercept. The y-intercept is right here, 560, if this is in standard form, and we're jumping ahead to objective 12 a little bit, but standard form reveals the y-intercept. So I know the y-intercept is 560. So what I'm going to do actually is I'm going to adjust my window. Let's adjust our window. And we need to think, okay, so x-axis, do I really need negative 1,400 as my x-axis all the way to a positive 1,400? Well, x represents time in seconds. So let's start from 0 seconds and let's go all the way to, I don't know, 10 seconds. And when I do that, I produce a much better graph of the parabola. Okay, this is a much better graph. Now I can see its shape. So I can see that it started at 560. It reaches a vertex at 1,576. So the highest it goes is 576. And then I see values reflected. For example, after 2 seconds, it's back down to 560 feet. And it continues this all the way to, let's clear this, all the way to 7 seconds, all right? And if I look at this graph, now that I've adjusted the window, I should know that this root, this x-intercept is when the object hits the ground because the height is now 0. So 7 seconds, 0 feet up in the air versus, let's say at 1 second, it was 576 feet up in the air. My y-intercept, 0,560. I can actually go back here to find my other x-intercept, negative 5, 0. So at negative 5 seconds, it's 0 feet in the air. That doesn't make any sense. The context actually starts with a domain of 0, ends with a domain of 7. And that is basically the features of the graph that we need to be knowledgeable of. All right. Another reminder that this vertex 1,576 is also known as a maximum. It is the highest value. And that is basically all we needed to know about the graphs of these. One last little thing. Notice how the a value right here of standard form, because standard form contains an a value in front of x squared, a b value in front of the x, and a c value as a constant. So the a value will determine whether or not you have a parabola that opens up, positive a values, or a parabola that opens down, negative a values. We have a value of negative 16, so that should tell you why this parabola opens downwards, all right, which means it has a top vertex, a maximum, all right? So enough about the graph. Let's look at what we learned about factored form versus standard form, but that'll be in a second video because I have like 20 seconds remaining. So that was a 5-minute crash course into quadratic graphs. Once again, the important features are the y-intercept, which you see as the constant in standard form, the vertex, which is a maximum or a minimum, in this case a maximum because my a value is negative, and then the roots, which there will be 2 roots. In this case, only one of them makes sense. It's the x-intercept of 7.